Okay, we're going to start solving equations and inequalities in Chapter 2. So our objectives are to determine whether a given number is a solution to a given equation, and we're going to solve equations using the addition rule. An equation is a number sentence that says the expression on either side of the equal sign represents the same number. So we're going to try to balance everything, make sure it works. So let's determine whether the equation is true or false or neither on this one. 4 plus 6 is 10, so 10 equals 10, so this is true. 8 minus 3 equals 5. 4 does not equal 5, so this is a false statement. And then x plus 9 equals 21. It's neither, because we don't have an answer to this one yet. We don't know what x is. It's just an unknown number until we're told differently. Okay. So the solution of an equation is any replacement for the variable that makes the equation true is called the solution. To solve an equation means to find all of its solutions. Notice this word right here, all of its solutions. So for example, how do we find what this one is? We'll just think back on this. It says determine whether 8 is a solution of x plus 12 equals 21. So if we were to plug in 8 for x and perform our operations, so we have 20 equals 21. Is that a true statement? It does not equal, and you're going to see that symbol. It's the equal sign with a line drawn through it. So this is false. Okay, equivalent equations. Equations with the same solutions are called equivalent equations. And then the additional principle for equation, any real number a, b, and c, when you have a equals b, if you add c to it, you have to do it on both sides. I think of that as like equal opportunity. Again, what you do to one side, you have to do to the other side. So we're going to work this one. And the way to do this is you're thinking about what could go in the place of x. What you want to do is you want to get the x completely by itself, so you're going to subtract 6 from both sides. Think about it. You want to make this 0. So if you have a positive 6 and you take 6 away, that gives you 0, but you want to do that to the other side. So now we have x equals, and you have negative 9 minus 9, so that gives you negative 15. So the next thing you need to do is you just need to go back and check. So if we go back and check, we can say negative 15 plus 6, let me write that a little bit better, plus 6 equals negative 9. Now we're trying to balance, so negative 15 plus 6 does equal negative 9. Negative 9 equals 9, so this is true. So we checked our work. Guys, there's no reason for you to make a mistake in this class on these assignments if you check your work. Alright, let's look at this one. Again, there's a conversion error. So this really says negative 8.3 equals y minus 17.9. That's the original equation. If you've got your notes, you should be able to figure that out. So it's written with the variable on the other side, and you guys aren't used to really looking at it that way, but we're going to keep it there. I want you to get used to seeing it. So we need to get the variable by itself. In order to get the variable by itself, 17.9 is being subtracted from it, so we need to add 17.9 to both sides. Whoops, let me make that a 17, not a 19. Alright, so that gives us y on the right hand side, and then negative 8.3 plus 17.9 gives us a positive 9.6. And so now we just go in and we're going to go check it and make sure that we are right. So if we say negative 8.3 equals that 9.6, that's what we're going to plug in for y, minus 17.9, I know I ran out of space, Negative 8.3 does equal negative 8.3 on both sides. So this is true. So our solution checks. So 9.6 is our solution. Okay. Our last problem, or our last example, is negative 1/5 plus some unknown number x equals 7/10. Well, we're going to do the same thing. We're going to add 1/5 to both sides. So now our problem is x equals 7/10 plus 1/5. You can use your calculator, use your ABC key, whatever works for you. But I'm going to, because we don't have a common denominator, so I'm just going to quickly look at it and think, okay, 5 and 10, our common denominator is going to be 10. So I kind of go over to the side and work. The 7/10 is going to stay the same. But if I have 1/5 times 2 times 2, because I want the bottom to be 10, and so whatever you do to the denominator, you have to do to the numerator. So then I get 2/10. So I'm going to add 2/10 here. So x equals 9/10. Now we're going to go back and plug in and give us some room here. So we're going to go back in and we're going to plug into the original equation and see if that's what we get. Negative 1/5 plus 9/10 equals 7/10. So we know that negative 1/5, when we go back and convert that, we get the 2/10. So if I say negative 2/10 plus 9/10 equals 7/10. 7/10 does equal 7/10. So 9/10 was our solution because this was true when you plug it back in to check. I will assign homework in class. So make sure that you are in class and be ready for your groups. This is for the flipped class. Alright, see you in class.